So we have this formula C equals lambda nu, and that's a weird looking formula, but here's what all those strange symbols mean. So C is a constant, and that's always going to be the speed of light, and it's always going to be this number. It never changes. Lambda is just the Greek letter that represents wavelength, and that always needs to be in meters. That's just because of our units in the speed of light are meters per second, so those meters have to match. And then we have our Greek letter nu, which represents frequency, and the units for that are hertz. And hertz is just a fancy word for per second. So what that means, so frequency is how many waves pass in a second. So that's going to be waves per second. So whereas the meters is here, the per second is here. So that's how our units line up. So this example says a wave has a wavelength of 656 nanometers. So there's our wavelength. I'm going to stop right there because remember our wavelength needs to be in meters. And what we have right here is a conversion factor that says 1 nanometer is the same as 1 times 10 to the negative 9th meters. So we can go ahead and set up a T-chart for that. Our given is 656. 1 nanometer is going to go on the bottom. 1 times 10 to the negative 9th meters goes on top. So we're going to have to multiply those numbers to get our answer. There's a couple ways we can put this in our calculator. One is to use the E button, and I posted a video of how to use the E button using the same calculator. So you can watch that if you want. All calculators have that kind of E button. It just might look a little bit different than that, but they all work the same way. But I'm going to show you how to not use the E button and still type this in your calculator correctly. So anytime we're using scientific notation in our calculator, we always want to put parentheses around the whole thing that is scientific notation. So I'll show you what that looks like. If I'm going to multiply these, I'm going to type in 656 times parentheses 1 times 10 to the negative 9th close parentheses. Okay, so you see how I put that whole thing in parentheses, and then whenever I hit enter, I should get my answer. Now this calculator just gave me a really big decimal, but there's a way to turn that into scientific notation. Your calculator might be a little bit different, but on this one there's a little button that says Sci right there. So I'm going to hit second and hit that, and then go over to where it says Sci, and it tells me now that is my scientific notation. So really my wavelength is 6.56 times 10 to the negative 7th power. So that's the wavelength that I actually want to use in my formula. So I'm going to plug in all the pieces. So we have C is my speed of light. I have 3.0 times 10 to the 8th in parentheses is equal to my wavelength that I just calculated in meters, and I'm going to put that in parentheses as well, times our frequency, which we said in the question we want to know what the frequency is. So that's what we're calculating. So I'm going to leave that as a V, or you can make it an X if that makes you more comfortable. And now we need to do algebra to solve. Since I'm solving for my frequency, I'm going to try to get that by itself, and I'm going to do that by dividing both sides by 6.56 times 10 to the negative 7th. Remembering to keep that in parentheses at all times. That cancels out. So what we have is our frequency is equal to this number divided by that number. So typing this into our calculator, we're going to keep this top part in parentheses divided by the bottom part, which is still in parentheses. If I get that in my calculator correctly, this is the answer that I should get back. But when I go to put this into Canvas, if I want it to count my answer correct, I need to round to 2 decimal places, and I need to enter it in the correct format. And so the way that needs to look exactly in Canvas is 4.57 the 3 makes the 7 stay the same. If it was 5 or more, this would be an 8. I'm gonna write the letter E. The letter E stands for times 10 to the something. Okay, so that E just takes the place of all of that, and then my exponent afterwards. So the correct format to put this into Canvas would look like this. We also have this other formula that can be used to calculate anything involving energy. So in this formula, we have E stands for the energy in joules. Joules is just a unit we use for energy. H is another constant. It's a different one. It's called Planck's constant, and it's just always going to be this number. And then the units for that are joules times seconds. And then we have our frequency, which is the same as above. This question asks, what is the wavelength of a photon with an energy of this number? So we know this is our energy. So let's go ahead and fill that in. 7.25 times 10 to the negative 19th. I am going to put that in parentheses. And we're going to set that equal to, fill in our Planck's constant in parentheses. And the other thing in our formula is our frequency. You'll notice this question is asking for the wavelength, but this formula doesn't calculate wavelength. It's going to calculate frequency in this case. But what we can do once we find the frequency is then plug that into our wavelength formula to solve for the wavelength. I went ahead and did that math, so this is going to divide by the same number to cancel it out and get the frequency by itself. And I got 1.09 times 10 to the 15 hertz. So now I'm going to take that frequency and plug it into my frequency formula. So I have C equals lambda nu. My C is my speed of light still, 3.0 times 10 to the 8th, keeping that in parentheses. It's equal to our frequency times our wavelength. This time we have our frequency, which is 1.09 times 10 to the 15th, times our wavelength is what we're solving for. Divide on both sides, cancels out. This is what you need to type into your calculator. And putting that into my calculator, this is what it gives me. That's what it looks like. But remember, I'm gonna round to 2 decimal places. And the way I'm gonna actually put that in Canvas is like this.